Okay, so we're going to move on to an equation that's used in solving electric circuit problems. It's called Ohm's law. It's a pretty simple little formula, and we'll talk about that and then get into electric circuits in the next unit. So we're on Ohm's law, the instruction section of Ohm's law. That's the fourth lesson, and it's square number 2. So current is the amount of charge that passes through a section of wire each second. A current of electricity is like a current of water in a river. It's how much is flowing. You can almost think of it like the speed of the electrons, but that's a loose definition. But it's how fast they're flowing through a certain area. The formula for current is I. So current is designated by capital I. The unit of measure we're going to get to is called an ampere, and it's the change in Q. What that means is change in charge or amount of charge. Sometimes it's just expressed as Q, and that's fine, but they put delta Q of each change in. And that's measured in coulombs, and then time is measured in seconds. So I is current measured in amperes. That's often called amps. Q is charge measured in coulombs, and T is time measured in seconds. The symbol, that triangle symbol, delta, the Greek letter delta, means changing. You'll see that in math and science classes in a lot of different circumstances. Okay, so the equation means that the current in amps is the amount of charge that passes through a section of wire per second. 1 coulomb is the charge on about this many electrons, a really big number of electrons, yet it's not a very strong charge, so that just shows you how little charge there is on 1 electron, and that's the number of electrons it would take just to make 1 coulomb of charge. Okay, now in square 3 they give you just a simple little problem based on that formula. And there it is, and so they say it takes 8 seconds for 12 coulombs of charge to flow through a wire. How much current? So I equals delta Q over T, 12 over 8, and that's 1.5 amps of current. All right, electric circuit. So an electric circuit is a controlled flow of electrons designed to produce some useful work, such as lighting a light bulb, running a computer, or powering the San Diego trolley. An electric circuit is to electrons what pipes in your house or apartment are to water flow. Pipes provide specific places where the water flows, and the electric circuits do the same for electricity. How much current flows in an electric circuit depends on 2 things: the amount of voltage and the resistance. Voltage is the amount of electric potential between 2 places that cause electrons to move. You can just think of it of how hard are the electrons being pushed in a certain direction or through the electric circuit. Okay, so when you hold a book and then release it, it falls from a place of higher gravitational potential, your hands, to a place of lower gravitational potential, the floor. The voltage is basically electrical gravity. It causes a charged particle, specifically electrons, to move from a place of higher electrical potential to a place of lower electrical potential. So all of these things that we're talking about in electricity are very similar to gravity, and you can think of them in those terms. It helps you to understand them a little bit. Okay, square 6 is fill in the blank, complete the statement. Electrical potential difference is also known as voltage. All right, square 7. So resistance opposes the flow of the electron charges through the circuit. So a wire has more resistance if it's long, if it is thin, if it is hot. So longer wire is going to have more metal for the electrons to have to fight their way through. If it's really thin, it's like walking people down a hallway right here. It's harder for people to move from one end of a hallway to the other if it is long and narrow. Okay? And also, generally when we're doing circuit problems, though, we don't treat the wire as though it has any resistance. We treat it as though it has no resistance, just to make the problem simpler, because it's a little complicated how to calculate the resistance through a wire. So we treat it as though it's 0 resistance, but it actually in real world does have resistance. Okay, resistance also occurs in a circuit element called a resistor or a load. So what is a resistor? A resistor is a device designed to produce resistance. Resistance limits the amount of current that can flow across the resistor and causes the voltage to drop across the resistor. A load is a device in the circuit that the circuit was designed to power, such as an electric fan or a computer. So here's a couple of key points to remember. Current does not change moving across a resistor when we do start doing circuit problems, but the voltage does drop. From one side of the resistor to the other, there's a voltage drop. Now, you may ask, why do you want a resistor if all it does is cause the voltage, limits the current and causes the voltage to drop? It sounds like that's wasting energy. Well, think of it this way. If there's a water pipe coming from the city into your house or your apartment, it has a lot of water under very high pressure. You wouldn't want to take a shower or wash dishes under that high pressure. So what do? In your shower, you have a shower head that limits the flow of how much water can come out so that it's just the right amount that you can take a shower, or just the right amount coming into your kitchen sink so that you can wash the dishes without too much water coming out. So the resistor does the same thing. It limits the amount of electricity that can go into a circuit element such as a fan or a light bulb, so that it won't burn out the fan or the light bulb. And so resistors help you to control the amount of current and voltage you have at various places in the circuit. Okay. So this is square 7. They just gave you a little question. Use the drop-down menus to complete the sentences. A thin wire has more resistance than a thick wire. A short wire has less resistance than a long wire. A warm wire has more resistance than a cool wire. Okay, so here is Ohm's law, and what it says is voltage equals current times resistance. That's the standard way most textbooks present this. The Edgenuity videos present it this way, and I like this way better. The current equals the voltage divided by the resistance. So I think that the equation on the right makes the relationship clearer. The amount of flow of current is a battle between the forward push of voltage and the backward push of resistance. So if you look at this, how much current, how much those electrons are going to flow will get bigger if the voltage, that's the push, gets bigger. If the number on the bottom, the resistance, gets bigger, that's an inverse relationship, then the current will be smaller. So if this number gets bigger, current gets bigger, the amount of flow of electrons. If this number gets bigger, resistance, then current gets smaller. So just a little football analogy here. You got the offense, that's the voltage, they're pushing forward. You got the defense, they're like the resistance pushing backward. The football is the electrons, except it's a whole lot of electrons. And that's basically the battle that's going on here in the circuit. And depending on the size of the voltage in relation to the size of the resistance will determine how much current flows. So how much the electrons, the footballs, move depends on the strength of the voltage, the offense, versus the amount of resistance, the defense. Okay, and in square 10, they just give you a simple little Ohm's law problem. It's a very easy equation. What is the current in a circuit with a 6-volt battery and 2 ohm resistor? So current is what they're asking for. They give you the voltage 6, they give you the resistance 2, you divide, you get 3 amps. Sometimes you're going to want to use this formula, and sometimes you're going to want to solve for voltage and have V equals IR. So you use both of those formulas. Okay, square 11. In words, Ohm's law states that current is directly proportional to voltage, so it means it's on top, and directly means there's no square here. It's not V squared or I squared or anything. It's just a straight linear relationship. V goes up. If you double V, you'll double I, in other words. It's proportional to voltage. Directly proportional means there are no powers such as x squared, x to the third, and inversely proportional to resistance, which means that as the resistance goes up, the current goes down. And as the resistance goes down, the current goes up. You get more flow of electrons. Okay, so we wrap up this short lesson with just another question in square 11. How does the current in a circuit change if the resistance is doubled? What that'll do is, if you change the number on the bottom, I equals V over R. Basically, if you double this down here, you make it times 2. What you're really doing is multiplying that side by 1/2, so you're multiplying this side by 1/2. So that means you cut the current in half. If you double the resistance, the current gets cut in half. All right, and that's the end of that lesson. So the next lesson we'll actually do some circuits.